Morning. I originally entitled the talk Software Packaging with RPM Demystified. Back in January, I sent in the proposal. But the more I get into it, the more I realise that I'm still mystified. I'm going to cover package building, not package management, because package management is essentially simple. Yum. Even Puppet Chef can install your packages for you. But there is a lot of detail around package building. I'm a software engineer with Semantic.cloud working on the Message Labs email infrastructure. And I'm also an author working on the RPM handbook. I looked at RPM from two perspectives. One is I don't understand it. We have a large infrastructure at Message Labs, something like 10,000 mail servers, and everything has to be packaged as RPMs for deployment. And using enterprise operating systems, we have different versions. Some of them are quite old. And what you need to know is not well documented in RPM. So I must apologise that the talk is not exhaustive, although it might be exhausting. So I'm going to talk about what RPM is, then move on to building the RPMs, different aspects of it, and then just a few pointers to sources of further information. The significance of packaging. Back in 2007, Ian Murdoch on his blog said that package management is the biggest advancement that Linux has brought to the industry. Prior to RPM and Debian packaging, most packages would be installed from tarballs. You might have to edit the make file. There was almost certainly no guarantee that you could remove what you'd installed, even if what you'd installed had destroyed your system. Debian and RPM packages evolved around about the same time. 93, 95 was when they sort of first emerged, and they are comparable, roughly, in functionality. RPM provides a straightforward and consistent way to manage your software. Puppet Chef, CMSs like that will deploy software either in RPMs or Debians, or use Yum, quite simple to install your software. It's a fundamental building block of your distribution, and as well as being used within the distributions, independent software vendors, crossover Office, Oracle, whatever, they'll be packaged as RPMs. And the other large use case is for internal use within data centers. And a well-constructed package will give professional impression of your software. And the converse is that if it's not well constructed, then people might not even bother giving your software a second chance. RPM came with a sort of philosophical view of how software should be packaged, aimed both at end users and package builders. So from the end user perspective, it makes it easy to upgrade, powerful to query what you've got installed, and verify what you've got installed. From the developer perspective, they took the approach that you start with pristine sources and patch that, and by defining your dependencies, you should be able to reproduce your builds. And the issues, it is poorly documented. The man pages don't give all the options. There isn't a spec man page. There isn't an RPM macros man page. It's old. It's it's about 20 years old now, but it is still evolving. I was at the Red Hat DevConf in Czech Republic a couple of months ago, and there was discussion there about new features which may go into Fedora 19, 20, 21. The enterprise distributions lag behind these developments, and features are probably not going to be there for quite a few years to come. There's a lot of detail, and some of the detail is distribution specific, although the developers are working on bringing things together to a certain extent. And then there is information and there's misinformation out on the internet. There are thousands of how-tos on how to build packages, and some of them are wrong. So just a perspective of what versions of RPM there are out there. We use RHEL 5 quite a lot. That's using the RPM from 2008, and RHEL 5 is still going to be around in 2020. Up till about 2005, RPM development languished. The maintainer, left Red Hat and took development with him. Nothing much happened. SUSE, Red Hat stayed on really old versions, and then they came together and relaunched the rpm.org website. And then since then, there's been a certain amount of development of features. So RPM, what is it? It is obviously a number of different things. It's the package file format, it's the installation system, it's the database, it's configuration files, a set of runtime tools, and also libraries which are used by the tools themselves and also by the packaging tools, I suspect by CMSs as well. It installs, erases, updates. It checks dependencies within a set of packages, but actually it's the upper level packaging tools, Yum and PackageKit, that will do the dependency resolution. So RPM on its own you give it a set of packages, and it will check whether the dependencies declared within that set and installed on the system are consistent, and throw up its hands if they're not. Whereas Yum will go and fetch stuff to solve the problem. And it comes with a tool which generally nowadays is a separate package, the build tool, RPM build. So I'll look at building packages. Two concepts which are quite important are dependencies and macros. We'll go on to the details of the build process. Dependencies are fundamental. Ensures that when you ask to install something, if the dependencies are properly specified, that you get all the prerequisites installed as well, and that if you try and remove something which your software depends on, it will warn you against that. And as I say, that is dependency checking, not dependency solving. Dependencies, they're expressed as capabilities, which are just text strings. There's no real semantic meaning to them. They're just checked by the RPM engine. RPM build will automatically take the name of the package and include that as a capability. Other capabilities are sometimes known as virtual packages. So, for example, SendMail, Exim will provide the capability of MTA. There are other capabilities which have a little bit more meaning, like RPM feature, which RPM lib features like compression mode that's required and stuff like that, and the various interpreters, Perl, Python, etc., express what they provide as modules. You'll often have a module distribution which contains a number of modules. Each of those modules will be expressed as a separate capability, and you should require the capability rather than the package itself, in case because different packages can provide the same capability. For the packages, they're versioned, obviously, and the scheme is epoch version release. Those are, if you specify that you need certain minimum or maximum versions of a package, then there are rules for comparing versions. Basically, epoch, a single integer, will trump any lower epoch version, but within version and release, things aren't so simple, or rather, RPM takes quite a simple-minded approach to comparing version strings. It doesn't understand all the myriad of versioning schemes that are in the wild, so it says, right, I just split on alphanumerical, split into strings of numbers and alpha strings, and then compare that sequence element by element. Numbers have leading digits removed, so you get things like 1.0010 is greater than 1.9 because 10 is greater than 9. 1a, lowercase a, is greater than 1b because a is ASCII-betically greater than, the lowercase comes after uppercase in the ASCII table. Epochs, as I say, version 1.0 with an epoch of 3 will trump version 99.999 with an earlier epoch. And then the separators don't actually matter. So dots can be replaced with underscores. RPM doesn't care. And then a 3 ABC is the same as a 3.abc or a 3 underscore ABC. Macros are, again, fundamental to the operation of both RPM and RPM build. All the RPM tools initialize themselves from macros. For example, %_ top_dir says where your build area is, and things like binary payload says whether it's going to be compressed with XZ or gzip compression. These are defined in userlib RPM macros and a number of other files, etc., RPM and macros.star. And the macros file itself defines 250 macros, and there are another 80 or so commented out. It's quite well documented, or commented rather, so it's well worth having a look at that. Those figures are from RPM 4.10, Fedora 18. I've actually got, I think, about 6 source trees open, dating back from 4.42 to 4.11, and you can see sort of things coming in, coming out. That looks like a good idea. No, it wasn't. Let's rip it out. So the RPM macros come from various sources, macro files that I just said. You can define them on the command line. In those two places, you don't specify in RPM macros, you specify % macro name and then the definition. -d, you specify the name and the definition, but in spec files or within nested macros, you use %global or %define. And previously, or a while back, everyone just used %define. You should use, if you want something with a global scope, you should use %global. There was actually a bug in garbage collection, so when a nested macro, the scope ended, it didn't clear up the symbol table, and your locally defined macros spilled out into global context. That can bite. I'm not quite sure what version of RPM that changed in when they fixed the bug, broke several spec files. And also RPM internally, when you specify name or release or version in your spec file, it will create a macro. And there are, I think I've identified about 30 or 40 internal macros. Again, they're not documented. Some of them are mentioned on various pages, especially the Fedora packaging guidelines. But I think even the maintainers are sometimes surprised at what they'd forgotten. Macros can either be simple macros or parameterized. If they're simple, then they get evaluated immediately. The expansion gets evaluated immediately, whereas a parameterized macro will partly expand the macro as it reads it, but then also expand it when it evaluates it as well. To use a macro in spec file or within a nested macro definition, just percent name or enclose the name in parentheses. If the macro isn't defined, you'll get percent name in your output, which is not how other macro languages work. But if you don't want the macro name to appear if it's not defined, then you use conditionals. Percent comma name will expand if the macro is defined. Exclamation mark name if it's not defined. You've got conditionals, shell escapes, messages. Error will stop execution, output the message, and then stop the build. And percent dump will just give you pages of the current state of macro symbol table. Yeah, building RPMs normally from sources and patches, although, of course, you get some packages which are just a spec file. They contain enough within that. Some people do nasty things like create a package from the file system. That's not really how it was intended to be used, and it certainly isn't going to make for a reproducible build. The GNU coding standard is actually quite has a good chapter in it on things like auto tools, which is the GNU way of building software, and it's the way that RPM build gives you the macros to let you follow that build process. Yeah, spec file. It can be in a tar file. It'll locate a spec file within that, and the spec file can define multiple packages. Spec file should also specify what's needed to build the software, and there is a yum util to actually parse the spec file the build requires and do a yum install of what's needed. That's used in mock. As the build process, again, it seems to be obvious, but if you look at it, it's actually fairly complex. It goes through a phase of initializing itself from the macro files. It reads the spec file, expanding macros as it encounters them, but the spec file is not defined by any grammar or anything like that. There's actually a parser for each section of the spec file, so it will say, "Oh, I found an install section. Let's go and invoke the parser for that section." So the documentation is the source code, but the source code is fairly hairy. it goes through the stages of the build scripts defined in the spec file to install to a build root, a proxy for the root file system, and then runs scripts that by default are defined by macros in the macro file to find the dependencies and the capabilities. It looks for shared libraries, user bin, executables, that sort of thing as dependencies. And then it will construct binary and or source RPM depending on what options you give it. And as I say, don't build as root. It's going to be executing shell scripts. If you build as root, you get what you're asking for. And just because you can build it on your system doesn't mean that it will build cleanly or that it will install cleanly. Mock is very useful for testing the dependencies. It's the basis of Open Build System and Koji, but it's actually quite straightforward to use standalone. Build environment, as I say, is defined by a set of macros. You probably know that you can put %topdir in your .rpm macros config file, but you can define it on the command line and just sort of build in the source directory, create the set of directories and just sort of say, build my RPM here. There is a tool from the RPM Dev Tools package which will set up those directories, but it will only do it in your home directory. So, spec files. A complete specification of the package, metadata, dependencies, scripts to describe the build process, manifest of what's going to be installed, and what I'd call administration scripts for install arrays, verify. And one of the aspects of its age is that the syntax wasn't really thought through properly. Percent can be anything. It's a macro, it's a spec file section and file attribute. Because each of the section parsers is independent of each other, you get things like %doc is only recognized in the file section because it's the file section parser that implements the recognition of that. Another point to bear in mind is that you can have comments in your spec file, but if you put macros, you sort of say, I'm using this macro % whatever, RPM build is going to expand that, and if it expands to a multi-line expansion, then it's probably going to break your spec file, or possibly do something that you hadn't intended. Set of sections. The description section is often described as a tag, but it is actually, if you look at the parser, and it fits in with the other sections, and it is parsed by a separate parser. So I describe it as a section rather than a tag. And the build scripts all run with the Bourne shell, and there is one set of build scripts. There's one change log. The rest you can have separate sections for each of the sub-packages. So the process is fetch the spec file from specs, then the individual prep will take things from sources into build. Build will just build in that directory. Installs into build root, which is your proxy for the file system root. And then the files, processing the files section will generate the RPMs. you probably know what a spec file looks like. Don't really need to say much about it. One of the things that people seem not to understand is what the destr equals RPM build route is. Autoconf generated make files, pretty complex beasts, and they've got destr support throughout the make file. Essentially, anything that you install is going to put destr in front of your target directory. So you'll have prefix to say where in the file system you want your software to be installed, whether it's going to be user local or user. But when you're doing the build, you don't want to install into the root file system, so destr is your proxy for that. Yeah, not much to say. There is the preamble is everything that comes before the first section, or subpackages have their own preamble identified with %package. Set of keyword values. Each of them will generally generate a macro of the same name. So name is %name, version is %version, etc. Source and patch are slightly different in that they can occur multiple times, and that's done with a bit of hackery in the parser. And actually, the %setup and %patch macros aren't real macros. They're a bit of C code that pretends to be a macro and does things that you can't do in the macro language. Dependencies, by default, you probably don't need to worry too much about dependencies because RPM build does quite a good job of finding your dependencies. But you can provide them with provides, requires. Prereqs tag is deprecated in 4.6, I think it is, which is after rel 5 and before rel 6. So that's one of the things you find is that there are subtle changes in what's accepted, and what you take something, a spec file or a source RPM from rel 6 and try and build it on rel 5, and it just breaks unless people have been a bit careful about it. Zusa has got some soft dependencies. I think it suggests and recommends. There's talk at the moment about extending that and putting it into RPM 412, I think it is going to be. So it's going to be suggest, recommends, augments, and I can't remember what the fourth one was. But basically, you've got the dependency information can be provided by the main package and, say, by a plugin. So GIMP could suggest some common plugins, but other plugins that the GIMP project don't know about can say, we augment GIMP. Essentially, it's sort of tramp data that goes into the RPM file header for use by the package manager. As I say, RPM build, or RPM itself, doesn't actually do any dependency solving, only the dependency checking, so it's not really interested in that. Yeah, the dependency generators are run immediately after the %install section, but you also need to specify your build dependencies. I've just been putting together for work a build system for CPAN modules. So we use about 500 CPAN modules, and trying to maintain them when we upgrade the Perl version, etc. is just need to have control over it, and specifying the build dependencies and using mock proves to be quite a robust way of making sure that things work. And then also using mock to do the install. So you're checking twice, the build and the runtime. Each of the build scripts executed by shell, they're dumped into temporary files in var tmp. Prep section will use these two pseudo macros that I think if you specify rpm minus uppercase E for expand macro, you'll find that they don't exist, but they do in that context. So possibly calling them a macro is slightly misleading. The build process, there are a load of macros in the macros file to help. %configure does the right thing for most things. There are variants on that. There's also a variant on make, I believe. But most software that is well written will build like that. Install, I've talked about Dester. When things go wrong, it can be tricky, especially if your build has taken a couple of hours to get to the stage of install and something's broken. You can either execute to a certain stage with the -BP, BC, BI, but there's also the short circuit option to go straight to that stage. And there is a short RPM program in Fedora that we only discovered at work last week, which will fiddle around and pretend that you've got to, say, the install stage without having gone through your build. And the other way of debugging things is just put exit 1 or some sort of macro that will cause the thing to dump at a particular stage. I tend to just tar up the build area and grab the build script, make copies of that, and then just sort of manually go through. Management scripts. Each stage has got a before and after script. Generally, there'll be shell scripts, but you can specify your own interpreter. You've got before and after installation, uninstallation, but also before and after the transaction as a whole. Yeah, and on upgrade, you've got 2 versions of the package installed at a particular time. Installs the old version, then uninstalls installs the new version, uninstalls the old version. So it'll run install scripts from the new package and then uninstall scripts from the old package. And to distinguish, you've got the $1 argument, which will say how many instances of this package are going to be left when the operation has finished. So you can detect on install, if it's 1, then this is the first time the software has been installed, set up new users, etc. If it's 0 on uninstall, you're the last one out, switch off the lights. And the sort of things that you'll want to do is set up the resources, the users groups, services, cron jobs, alternative system, that sort of thing. And the scripts can be for the main package, or they can be for individual sub-packages. Just put the name after the script tag, or if it's a proper sub-package, so main package name hyphen something, then that's all you need. If it's a separate package name, you specify -n. Specify the interpreter with -p. Default is the Bourne shell, which may be bash on Fedora, but you can't guarantee that it's going to be bash. There's also, from quite a long time ago, before 4.4.2, there's a built-in Lua interpreter, which, I mean, if you're doing Kickstart and you haven't even got the shell installed, and if you want a pre-trans script at that stage, Lua is all that you can depend on. SH isn't there at that stage. You can also, you don't have to provide a script for the script tag. Invoking the program itself might just be enough, like ldconfig, to update library, LD, the shared object stuff. Specifying a program will create an automatic dependency on that interpreter. Well, you might want to say that you require it just for that stage with a requires brackets pre or something like that, which says I require it on installation, but it's not necessarily required afterwards. So the package manager is quite free to install for installation and then just remove it afterwards. So if you say requires pre whatever, then and you need it at runtime as well, you need to include a requires as well. Triggers are fun. I think I missed one out. I think there's a trigger pre-in as well. So again, similar to the install uninstall scripts, but this is run this script when some other package, the target package, is going to be installed or uninstalled. I think one of the FTP servers uses that quite extensively to configure what commands are available. So it depends on the version of glibc, I think it is, and sets up whether commands are enabled or disabled. And you've got two arguments, number of instances of both source and target package. Files lists, you can actually you can either list them in the spec file, or you can do things like build the files list in the build section, and then refer to that with -f, or you can have that could be one of the files in your sources directory. The attributes seem to be changing. There's a new %license to mark license files, although I don't think any distro has yet uses 4.11. I think Fedora 19 is going to be the first one to use 4.11. And then you can do things like, say, well, by default, RPM build will say, if you've got unpackaged files in build root, then that's an error. But again, that's one of the 80-odd macros in macros file, which you can set that to a false value, and doesn't matter. Or if you've got special requirements, you might have that in your RPM build command line to find or undefine it on the command line. One of the things that we used to find is that someone would build an RPM, they'd leave, somebody else would try and build it, and they couldn't build it. There's sort of silent dependencies on what was installed on the original developer's machine. Build requires ensures that, or using build requires in conjunction with mock ensures that you don't fall into that trap. And it's quite simple to do. Just set up a cheroot with mock, or use one of the, something like Zooza open build system, or Koji if you're packaging for Fedora. And of course, you'd also test the installation of packages that you've built on a different machine, on a clean machine. And yeah, RPM is evolving. And if you remember that RHEL 5 is still using the original version of RPM after the refounding of the rpm.org website. RHEL 5 doesn't know about any of these things, like build root is now silently ignored, group tag is no longer mandatory. Fedora has stopped putting group tags into their spec files. So one of the first things we have to do, taking a source package from Fedora and trying to build it on RHEL 5 is pepper it with group tags and stuff like that. Prior to 4.6, the default build area was user source Red Hat, and back 20 years ago, people didn't really worry about building as root or changing the ownership of Red Hat, of user source Red Hat, or SUSE if you're on a SUSE machine. 4.7 introduced GZ compression. RHEL 6 used that, which meant you can't even take a source package from RHEL 6 and install it on RHEL 5. And then you got 4.6 group tags no longer mandatory, and they sort of, okay, there are 3 tags that are mandatory in sub-packages. I think it's name, summary, and group. And then from 4.7, then it inherits group from the main package, introducing new macros. And this is just a fraction of what's in the release notes. That's where I've got the information from, the release notes, and trawling through the source code. So if you're interested, then look on rpm.org. There you can find all the information there. So another thing that's going to bite is that at RHEL 6, prereq is deprecated. I think later it's going to go away, and our old spec files are going to break.
It won't build anymore on RHEL 6.
Sorry?
If you have a prereq in your spec file, it won't even build anymore on
Yeah.
RHEL 6.
Yeah.
Once it says don't use it
Yeah.
anymore.
I think for very briefly they did internally translate them to requires pre, but
That does something completely different with
yeah, yeah. I think it's the sort of thing that gets put into a development release and then backed out. And there's more that I don't really have time to cover. There was an implementation of SE Linux policies. It was then rolled out because it wasn't good enough, and there's a new one coming along. Software collections is quite neat. That takes something like Perl, Python, Postgres, and build it separately from the system delivered version of the package. So for Perl, you could build, say, Perl 5.16. RHEL is still delivering 5.8, and it will install into opt RH, and then whatever the collection name, root, user, and then the complete user hierarchy. So your man pages go in there, everything goes into that, and then you have a command to enable a collection, and it'll sort of say, okay, I'll go off and pick up that installation. And it doesn't conflict, it doesn't overwrite the system installation of that package. It's something that Red Hat came up with for their developer tools product, which they wanted to have on different versions of RHEL. First surfaced about this time last year, but it works really well. We're actually using it to migrate from the operating system supplied Perl to a software collection, and then onto a higher version. But by moving from 5.8.8 provided by the operating system to a collection, we can then either do the upgrade of Perl or the upgrade of the operating system independently. It's quite nice. So yeah, there is a fair amount of information out there. One of the best places is probably the Fedora project wiki with information for package maintainers. OpenSUSE has got a similar portal. The stuff on rpm.org is a bit disorganized. and you really need to know if you're packaging software as opposed to other resources, then classic shell scripting and auto tools, and look at the GNU coding standards. And then I've just registered rpmhandbook.com. I'm working on as well as the book, I'm working on a quick reference card and stuff like that, which I'll put up there in the next few months. And thank you. If you've got any questions. That's only a fraction of the detail I found.
Sorry. One question you mentioned in the first slide, I guess, version compare for Epoch versions. Yeah. Is this specific to a specific RPM version? Or?
No, I think there was something called serials, which is mentioned in the maximum RPM book. But that is, I think, RPM 3 or very early versions of RPM 4. So from about 2005 onwards, epochs were already there.
Okay, I was just wondering because if I run RPM version compare on my machine, it shows a bit different output. So 1A is smaller than 1B, for example.
Depends on whether on capitalization and.
I just entered the same values there, so I was a bit confused.
Stop.
Well, that also might depend on which language you use and which environment you use for sorting. I found that if you use RPM version compare or RPM var CMP, that might look at try it with lang equals z, and that should work. Like explained, and if you use your own language, you might get different sorting there.
It should really use the C locale. Certainly, build scripts are run with C locale defined.
In the Debian world, we have Lincoln for quality checks. Is there something like Lincoln?
There's RPM lint, which will give you issues in the spec file or in source RPMs.
Thanks.
Yeah, there's a whole bunch of tools like FPM, which is the package manager, which will generate Debian packages or RPMs. It'll create a spec file for you. I'll put a resources section on my website when I get round to it. Alien is from the Debian world, which will do conversions between packages.
Are there any helpers available for building Ruby gems or, I don't know, CBAM packages?
Look at the Ruby packaging guidelines on Fedora or OpenSUSE.
I can answer that, especially for SUSE, yes. For Ruby gems, for CPAN spec files, for Python, there are helpers that can just simply, if you download the tarball or the gem, go over it and create a package for you. But I also have a question. Do you know the Open Build service?
Yes. Yes.
Because you mentioned so often that you should try to build a package more or less independent, so you can rebuild it again and again without any problems. And this is exactly what the build service is
Sure.
for.
Yeah, I did mention Open Build System. In a commercial world, you might not want to release or let your source code outside your perimeter. And for in a fairly controlled environment, then using mock gives you probably 90% of the.
No one? No one? Ah, okay.
Well, maybe because you mentioned it, and again, word of warning, pre-requires and requires pre. That's if you're used to using pre-requires, then became hard dependency. So if you pre-required something in your old RPMs, it had to be on the system. You could not remove it without removing the package requiring it. If you're using requires pre at the moment, it just is there for the moment when the pre-install script is running, and after that you can remove that. So just if you have pre-requires somewhere in your spec files, just remove that. The resolver is smart enough at the moment to look where it is required, where it has to come in this package, and just leave it at that. It should normally work. But don't think that requires pre just the same as pre-requires.
Yeah, there's also a order with requires tag which has come in relatively recently, and I haven't quite worked out myself what exactly it does. It's on my list of things to do. Yeah, the book and probably the quick reference card as well. I want to try and identify what changes there are so that you can say I'm running this version of Red Hat or SUSE and this isn't applicable to me, or that's what they mean when in that spec file that I'm importing.
No.
Okay, thank you very much.